So this is an OpenChain webinar, one of many. We crossed the 90 webinar point last year. In the last 5 years, we have covered all types of topics around how to manage open source, how to understand the big picture, and also how to do the very practical things to make sure that if you're checking for something like license compliance, you know how to do that. To make sure that if you're concerned about new requirements or regulations, let's say the NIST minimal requirements for SBOM, you know what type of approaches are being taken in the market. One of the things that has come up again and again and again has been the topic of automation and tooling. We come back to this topic very frequently, and our main way of doing it is to look at various open source tooling solutions to deal with stuff like open source license compliance, open source security assurance. There are many different types of solution. One of the solutions is to, of course, build something yourself. And some people have done that. But for most organizations, for most teams, for most projects, the key focus is to ensure that you can find something out there that is battle tested, that is proven. Now, there are many options, some of which provide pretty much everything you'd need. Examples of things used in production, open source, for open source compliance. There's Fossology, there's Open Source Review Toolkit, there's About Code. Today, we're going to take a look at About Code and where it is at in providing an all-in-one solution for things like licensing and vulnerabilities and more. Before we get started, this webinar, this meeting, as with all of the Linux Foundation meetings, is held under our antitrust policy notice. You can find the full antitrust policy on the Linux Foundation website. If you're from a Linux Foundation member company, you are welcome to ask any questions of our counsel, Andy Updegrove. And if you're not, of course, you may ask any questions of your own counsel. Long story short, the antitrust policy is there to make very clear how we have an open, collaborative, and sharing environment around these type of open community discussions. So today we're going to have Philippe, who's the CTO over at a company called Nextbee, and he's a lead maintainer of the About Code stack. So About Code is various different tools and data solutions, particularly scan code, Deja code, and vulnerable code, that can be used to address all of the key topics around open source license compliance and open source security assurance automation. The question for us is, what does it do today and how does it do it? And because this is an OpenChain webinar, because this is a community thing, as Philippe goes through some of the stuff they're doing, we also encourage questions, suggestions, and ideas. We're looking at open source projects, solving open source problems. We're powered literally by the community around us. And that means your ideas, your thoughts, your comments, everything from the code bases to implementation to other options in the overall community are extremely valuable. Now, before I hand over to Philippe, I'll just note that he is a very, very frequent contributor to the OpenChain project. And increasingly, his FOSDEM recap is one of the steady webinar highlights of our year. We're very fortunate to have him on this call, where very lucky to have him contribute to the project. And I just want to pause here because we have also Sebastian on the line, who's been deeply involved in founding and building out ORT, the Open Source Review Toolkit. We have people who are very practical in using code, using these solutions on the line. I just want to take a moment and say to everyone, we are light years ahead of where we were 5 years ago. We are galaxies ahead of where we were 10 years ago. So the fact that we're now going to talk about a full stack open source and open data solution is incredible. And it's an example of how all of us working together have made a difference. And Philippe, as I hand over to you, I just want to say, especially, my goodness, thank you for doing something like this, for bringing it out. And this is your, I think, second webinar on the topic. And so updating us on the latest situation. I'll hand over to you now.
All right, so thank you, everyone. I recognize a few names. So as Shane said, please feel free to interrupt me at any time. I'll be sharing my screen and the presentation, and I'll make the slides available to Shane after the presentation, so you can look at that separately and share them as you like. So I don't want to bug you with anything about the background and the reason why we're doing all that. There's a separate set of slides I have to share that. I assume that you're reasonably familiar with the problem of open source compliance, whether it's about license and security. Otherwise, you probably wouldn't be part of the call today. But what's important is in the approach here is open source tools and open data. So I'll do a bit of introduction. I may not go through the demonstration here. Again, sorry, I joined a bit late and I've not prepared all the screens for the demonstration. So I highlight some of the features and then I'll present the tools and especially what's happening with future projects. So if you don't know about me, I've been fairly active in the space. I'm both the lead maintainer of About Code, which is now, it's important, organized as an open source non-profit association, which is based in Brussels, Belgium. And I'm also the CTO of Nextbee, which is the major contributor and sponsor to About Code. I'm also one of the co-founders of SPDX and ClearDefine, and the creator of something called Package URL, which is a small identifier for package in the supply chain, which ends up being fairly handy and is used a bit throughout tools, SBOM standards and VEX standards and other tools and standards formats that exist out there. So that's for the intro. And as we know, the F in compliance is for fun, right? We're doing something which is important collectively, but it's difficult also for people to relate to something which may not always be perceived as business critical, though I think with the advent of security issues that we're all aware of, compliance with open source origin, license, and security issues is eventually just plain good business practice and plain good engineering practice. So tooling, there's a lot of critical parts we're still missing, especially in the context of the Cyber Resilience Act in Europe, which will impact you whether you're in Europe or not, by the way, because if you're doing any kind of business in Europe, your products, if they have some kind of digital component, so that's a very loose definition, will have to comply with the CRA if you want to continue receiving a CE marking. which means you're authorized to actually transact and sell this product in the European Union. And I think it's important to put that in the context of this area. We have similar regulations in the US. There's also emerging guidelines in India along the same lines. They're essentially one and the same. There's been new regulations and a new executive order from the Biden presidency that was issued a couple of days ago. We'll see how it pans with the change of elected president in the US. The CRA is a good, I'd say, common denominator across all these regulations. The point is that we need that set of open source tools for automation, because without automation it's going to be impossible. So if I look at the bare, and important, really looking at the bare essentials for compliance automation. One is to identify third-party code. It's not a resolved process. It's not solved. And if you're working the trench like I do, trying to figure out what is the third-party code used in a product, it's still a mess. There's no single open source, no single commercial tool that gives us a simple answer to eventually a fairly simple question, which is, given a product that I distribute, sell, deploy, what are the exact set of third-party code, package, their version, where they're coming from, that is included in this product? And of course, you want to know what's the license and what's the copyright, and are there known security issues? And so there's I like to say, there's really two techniques: scanning code, which is looking at the code in abstraction of the rest of the world and trying to find, oh, there's a package.json for an NPM JavaScript package, so therefore there's metadata. You can detect licenses, you can find a copyright and other clues which are locally present in the code without looking at the rest of the world again. And you can match code, which is the ability to match the code, meaning you establish a repository and an index of known open source code, and you're trying to fingerprint that code locally, your code, and match it against this reference and index. And again, as I said, beyond the package manifest, being able to identify the license, copyright, other origin clues is really important. So these are the techniques and the essential for identifying third-party code. Sadly enough, not all the tools use all these techniques. So you end up, as you probably do, using more than one tool. And I don't think there's a way out in the short term. The second thing, once you know your third-party code, is there's, generally speaking, a triage for issues. Specifically, I'm focusing on vulnerabilities today, but the same applies to license. For instance, if a GPL license package is included in a proprietary product, and your policy is not to have GPL license code, or maybe let's say it's a GPL3. The question is, what do you do with that? And typically the triage, when it comes to license, going to say, hey, how is this tool being used? How do we depend on it? Does it run in the same process? Is it a utility? Is this, for instance, a system package, say bash, that runs in a container that we use to deploy our application to run in a Kubernetes cluster? And if that's the case, then effectively the license implication may not be that there's an impact on the resulting license and specific obligations beyond bash and GNU bash. So that's the triage. You're already very well aware about licensing. When it comes to vulnerabilities, we want to look up in vulnerability database, ideally open. And there's really an important thing, which is it's common for a deployed application to have 10,000 packages. 10,000 packages means that any single day, you're going to have vulnerabilities that are popping up in the set of package version you use. And you need to be able to rank the severity and exploitability. Because otherwise, you're going to spend an inordinate amount of time to review and remediate these vulnerabilities. As an example, there's a whole class of, let's say, vanity vulnerabilities, vanity CVE, which is called the regular expression denial of service. If you, in your programming language, if you do certain type of regular expression, it could end up, in some case, running forever. So it uses all the memory of the computer it's running on, and eventually it makes your application stop, which means that potentially an attacker that interacts with your tool may craft a specific data entry in a form field or in an API call and trigger the case where you have this runaway vulnerability, runaway regular expression, which use all the resources. It's a very common issue, which is very often ranked super high, like super high severity. But in practice, it's very rare that it can be effectively exploited. And there's a lot of churn around that, because of course, when you, as a person in charge of reviewing these vulnerabilities, you see that you're going to spend a good amount of time to understand what are the implications, whether it really applies to your case. Very often it doesn't. That's an example. So being able to rank the severity, the exploitability is important. When I say exploitability is, can an attacker may take advantage of this vulnerability to achieve a nefarious purpose, stealing data, taking control of the servers, and so on. And it's even more important when not only there's known exploit in the wild, but also when there's scripts which are physically available, publicly available as open source, that can help automate that. So, triage. Ideally, as with matching and scanning, you'd like that to be package URL based, so you have a way to discuss across the different tools and standards. And the last step is to manage compliance. And if you're not already receiving some SBOMs, you will receive SBOMs from your different constituent partners, providers, contract developers, hopefully. If you don't, you should probably ask for them. And you will need to provide attestation and statements to the rest of the world. And that will take the form further of SBOMs for your code and eventually the aggregation of other code, plus what's called VEX, which is a vulnerability exploitability statement, which is essentially a bit like an SBOM, but dynamic, which says, oh, CV1, which is the regular expression attack on package foo, doesn't apply to me. Or it's not severe enough that it's something that may impact your usage of my software product or my digital product. That's what you would expect in a VEX statement. The point is to help your downstream users understand what's the concern and mitigation path, and eventually updates they need to do to remediate the vulnerability. Ideally, we'd want, again, this to be Perl-based, so using package URLs ensures that you'll be able to better communicate with other tools and SBOMs. So that's the essential. Now, what we're trying to do with About Code is basically provide a solution, open source solution, open data solution, which of the, so scan code with scan code, of course, match code with match code. And you may not be super familiar with match code because it's a new feature that's grafted onto the stack. Vulnerability with vulnerable code, and finally managing compliance with Deja code. And so if we look at it from another point of view, you have a knowledge base which provides reference data about license, origin, and security vulnerability. You have software composition analysis tools to basically scan the code, match the code, find out when you do a code analysis where this comes from. And last, management apps to aggregate the information and be able to manage the mess, hopefully helping remove some of the clutter. And if we drill down in terms of lower level features, that's the kind of things you have. And so typically the way we present and the way you get the most benefit would be to look at the higher level management applications. But each of these parts of the stack can be used also separately. There's no, absolutely no strings attached. And we're making sure as much as possible that we release each of the components as independent libraries also, so they can be used separately. We have, for instance, there's a small library we use to parse Python package manifest, which is used pretty much in the whole Python ecosystem and gets millions of downloads every month. It's a bit more work to maintain as a small library separately than integrated in the rest. It's a useful community service. And so who's using it? I hope you are. If you aren't, you should. It's both a blessing and a curse. It's a blessing because we have all these users. It's a bit of a curse, which is right now, as I said earlier on, Nextbee is the main sponsor as a commercial company that provides service to the development and well-being of the About Code stack and tool. That's we're not receiving much help from elsewhere, and it's going to be important because we realize that there's a lot of open source teams and open source compliance process that depends on the stack, and it's important for everyone that we make sure this is sustaining. That's why also we did put a non-profit structure in place to help support and welcome funding and sponsoring in this space. So let's look a bit at the stack itself. So scan code. So scan code, there's really two sides. The low-level library scan code toolkit, which is also the core detection for parsing package manifests and detect license. We're really putting a lot of emphasis on accuracy in the detection, correctness. To give you an example, we ensure when we scan code a container image, that would be in scan code.io, but it relies on scan code toolkit libraries. We ensure that we know exactly which exact set of files is part of a package. Sounds like a small thing, but when you're doing, say, a whole container analysis, it's a big deal. Typically, the part of the files that you have in a container, you very quickly have hundreds of thousands, if not millions of files in a large container. For instance, if you do a bit of AI and machine learning with a tool like called PyTorch, a base image for PyTorch as provided by NVIDIA is about 400,000 files and several thousand packages. And that's just the base image. It's not even the thing you may care for, really. You may need to add your own packages plus your own product on top. And so being able to know exactly that we have 400,000 files very specifically related to a bunch of PyTorch package, system package, maybe from Debian in that case, and knowing which files are which and belong to which package is super important, because that's the way to understand what are the other packages that were added on top. And what is the application payload, typically your code, which is the thing that really matters. And if you're not able to do this kind of a very, I would say, extremely accurate detection and relation of a file to a package, you don't know what's the payload, especially when you just copy and add files to a container image. You may not have any metadata. So we can work by subtraction, which is we know everything that happens to be installed by package A, B, and C. Therefore, this file here, which is not from a package, can be subject to specific analysis techniques like binary analysis, extensive and more detailed scanning, and so on. So this is the thing that happens mostly in ScanCode.io. The thing we've added also is the ability to enrich the scan results with code matching and just plain lookup. You know, we found a package. Say you have an SBOM, you upload that to ScanCode.io, and there's a package that doesn't have a license. Then we can do a lookup in the reference knowledge base to say, hey, what's the license for this package? And it could have been already scanned there, and it's available there, and we have the reference created data. Then that becomes a way to avoid the kind of churn that will surely exist, because when you're going to start in the next 12 to 18 months ahead to receive and exchange SBOM more frequently, it's going to be a mess. The quality and depth of information you're going to have across all of these different SBOM standards, it's not so much standards, it's tools. There's a lot of way you can interpret, for instance, SPDX, and tool A and tool B may provide different results for the exact same input. Okay, so that was the core scan code. The other tools we have here, really important, match code. It's almost ready then with a new feature called AI generated code search, which I don't think we had, or I was probably planning to discuss it last year, but now it's something we actively working on. And it's essentially a code matching and snippet matching engine with specific features which make it also amenable to detect when you have code that may have been generated by a generative AI, say ChatGPT, and assimilated using a large language model. It's also able, which is really important, to match whole file trees, exact file, and match also these approximately. So that's the way we went about developing match code is to say, let's look at the tools in the space. All of the tools are in nature proprietary, either they're proprietary code like say Black.Protex or FOSS-ID, or they depend strongly on proprietary database like ScanOSS. So we wanted to make sure we're providing first complete open source solution and open data, and also that we have a different approach. All these three tools I mentioned all use the the exact same core algorithm. So use one or the other, that really doesn't make a difference, because you'll get the same results and you get the same problems. If some of you have tried, evaluated, or are customers of these companies, you know the problems that exist, which is the huge volume of false positive. And so that's something we're trying to address there. It's already functional. It's going to be really promoted and announced more as something which is complete starting late spring, mid to late spring 2025, and something we're actively developing, as I said, at the moment. Trace code is a set of tools to trace component package files between development and deployment code base. It's also integrated in scan code, and inspectors are lower level specific tools for needs. For instance, there's an inspector for Go, which is able to do specific introspection of Go binaries. There's another one for Rust. There's another one for the general format for ELF binaries, and one for container and so on. The point here is that these are trace code inspectors are lower level libraries focused on one technology, reusable across other things. So, for instance, Python inspector, NuGet inspector are also used in addition to scan code in the open source review toolkit, ORT. And on the trace code side, we have a whole set of pipeline in ScanCode.io where you can throw at it a source and a binary of a package or a large code base. And the outcome is that we're trying to reverse engineer the binaries to find which source code has been used to build the binary. And if you provide the source and binary, it's assumed it's yours or it's first-party source code. And which source code is missing and is not available in the source that you think are being used. It's an unfortunately extremely common problem where we've worked with a large US-based American, US-based an American open source company that builds tools in Java and JavaScript. And they wanted to make sure they could scan with ScanCode.io everything. It was difficult for them because they use a lot of Java and JavaScript and many different build technologies. Very typical of large enterprise applications. Going in, they thought they had about 600 packages. If you looked at the whole universe of all the packages used in development, there were about 26,000, not 29. So it's a bit more than 600. The problem is that if you go about building SBOMs for 26,000 package, that's a mess for your end users. The reality is that the effective product as deployed has in the range of 25 to 3,000 packages. So the important things when you can trace is that instead of looking at what's potentially used in development or trying to guess based on some lightweight scan, so you don't have 600, you don't have 26,000. Really the core of the compliance that matters is this 2,500, which is something that for practical purpose is manageable. 29 is start to be a problem. Now, of course, we're talking about a single product. Imagine when you have 20, 100, 500, 1,000 different products, which could be device, and each of them may use several thousand development. I mean, you know the drill, right? That's your daily life, and that's the problem we're all trying to solve. It's a mess. So focusing specifically on what we call the deployment code base, which is the binaries, in the most general case, but it could be minified JavaScript is really important. And last, open knowledge standards, so package URL and version range. Very proud is something that started with scan code and vulnerable code. We had a very simple problem, which is how do you get to name a package in a report of scan code so we can do a vulnerability lookup? And we were trying to use the National Vulnerability Database CPE, so Command Product Enumeration, for that. And it was measurably painful and terribly work intensive and very unreliable. And so we came with this very simple thing called package URL, which happens to be now used pretty much everywhere. It's used in CycloneDX, in SPDX, but also in Oasis CSF and OpenVex, which is a standard at the OpenSSF for VEX. And also pretty much every open source tool in the space, most proprietary tools, and all the SBOM standards, including many vulnerability databases, for instance, some type OSS index, but not only, are using Perl. It's awesome because if we can speak Perl between two tools, then you'll be able to mix and match tools and integrate the tools in a much smoother way. It's recommended now by the US CISA, the German equivalent, which is called the BSI, and also the CERT India. I'm in discussion with the CV organization, CV Quality Working Group on the one hand, and folks from MITRE in the US. I had actually 2 calls with them last week to integrate Perl as a standard reference identifier in the CV schema. They already support that as a reference, but here would be to have Perl as a first class citizen there. So which is wonderful. They reached out to have this, and I'm going to help that as much as I can. Version range specifier is a way to store version range. Very important also because when you have a vulnerability in a package, typically you're going to have the expression of a range saying, oh, these vulnerabilities affects version 3 to version 5, not version 6, but also version 7. That's a fairly complex range, and this exists all the time. License data, so based on SPDX, but much more, because it includes also a large number of licenses that are not in SPDX. There's been a lot of effort recently done, by the way, by the folks from Red Hat and Fedora specifically, to add a lot of the licenses that were missing in SPDX to SPDX proper. And they've been using a lot of scan code toolkit to actually detect this license. So that's eventually, progressively, there's a lesser gap between what we have in license DB and what's in SPDX license list. We're still about probably in the range of twice the number. And it's just a matter of policy for SPDX, which cannot, as a matter of goal for the project, or doesn't want to have proprietary license. And we do track proprietary license as long as they are publicly visible, publicly available. It's important to detect these because in many cases there are more problems with a proprietary license and code under a proprietary license than code under an open source license. And now, package database, it's important. We are building and making this available. There's separate work to make it easily replicatable. And the point here is not, it's supporting code matching, but we're not trying to make that the biggest but we are trying to make that the best, not the best, sorry. The problem with many databases in the space is that they're centralized and too big to share. Now, if you're doing mostly Java and JavaScript, you may not care about having a lot of, say, I don't know, Python code or Ruby code. You may want some, but not all. And very often, what's interesting is having a knowledge base that's focused on the code you use, and that is your whole tree of dependency across all the products and your ecosystem, which my observation has been that even in very large companies and very large development organizations, software development organizations, we're talking about hundreds of thousands of packages, never billions or millions. Even for the largest software organization I know of, like very large social network, very large search engine, the number of third-party package used across all the products is typically in the range of several hundred thousands, which is much better than just boiling the ocean and everything. So the focus here is to have something that can be easy to subset, easy to install, and work on-premise for private operations, not too big as other databases exist. Last vulnerability database, I'm going to zap a bit to go then very quickly to the new project. Here, what's important is that it's not really a database of vulnerabilities. It's a database of vulnerable packages, and it makes a big difference. Most of the database in the space, be it commercial or aggregated open source like OSV, are database about vulnerabilities. Their lead and key identifier is a vulnerability. And there's something which are really weird. For instance, the National Vulnerability Database in the US is late to process many vulnerability records, and they may publish vulnerabilities without telling in a structured fashion which software package and which software, in their case, they call that product, it applies to, which is complete nonsense. It's like a vulnerability is a bug. A bug applies to a piece of software. There's no such thing as a vulnerability that exists in the ether without knowing which piece of software it's for very carefully, very specific. So we're trying to make it the other way around. We are aggregating data from OSV, GitHub, GitLab, NVIDIA, and others. We're also going to project upstream to get the, not here says, but actually the word directly from the horse's mouth, meaning advisories as published by the open source project upstream. Still a huge amount of work there, but at least we're trying to do something slightly different. And again, the important thing is keyed by package URL, meaning that if you can collect a package URL, then you can easily make a lookup in the database. Same thing, it's designed to be also fully self-hosted on-premise, and we're working on tools to make it easier to share the core data without having to recollect everything. Then last, Deja Code. So Deja Code, you can import and export as bombs. You can manage a product portfolio, what they're made of, apply policies, and we're working on a whole series of tools which are actually already available and released to manage the vulnerabilities in an active fashion, so you can determine what vulnerability apply. Are they really expressed in the context of a product, and putting all this information in perspective. So I'm gonna go now very quickly to future projects. So AI-generated code search, as I said, is support for not only detecting AI-generated code, but also matching snippets with different algorithms. Crevex is a project, and by the way, these are funded in part by the European Union. Crevex is a project specifically for vulnerability exploitability exchange. It's a set of extensions and new modules in Deja Code. And maybe I can do a very brief presentation, like really 1 minute demo on what you have here. I'm in Deja Code. I'm looking at a mock product, and I can see that this product version has known vulnerabilities. And I can then effectively manage and track my vulnerabilities both at product level. I can drill down into packages. I can see, for instance, in this package, log4j1217, I don't have just one vulnerability, but I have like 7 of them with different risk score. And important thing for you is these things we call the risk score, which is a computed risk score that takes into account different severity scores, whether there's non-exploit and exploitability. And then eventually you can manage that globally across all your products. And you can also determine how exploitable it is. So I won't go into a full demo because we don't have the time, but that gives you a bit of an idea of where we are with this Crevex project, which is essentially done. And if you go to Deja Code documentation, if you go to the Deja Code documentation, you have a bunch of extensive tutorials, which first will tell you how to install Deja Code, but also how you can manage product vulnerabilities, load scans, load S-bombs, and manage vulnerabilities across your portfolio and package of products. So that's Crevex. We have also a project that's just about to start with the software heritage project, which is based in France. And they have a large project to find ways to, I would say milk, it's not a good term, but collect and express the data that's available in billions of code files available in the software heritage archive. And we have on our hand, they want to, of course, scan everything with scan code, so to have reference scans and license detection and copyright detection and all that good stuff, and package detection across everything out there. Actually, it's probably inching towards more 30 billion now. We're working with them to support this, and at the scale of software heritage, everything is different. Scanning 20 billion files is a problem of its own, and it's a different sphere of issues. So there are specific issues that we are dealing with. And last but not least, we're working with folks from the Eclipse Foundation, but also some folks from ART and others to deliver a project that's called Octet, which is a well-rounded, documented open source solution to help specifically small and medium enterprise, but that's not limited to that, with cyber resilience act compliance. So I'm a bit overboard. We don't have a lot of time for we don't have a lot of time for questions, but I guess that's it here.
Well, you know what, Philippe? let's open the floor anyway. Does anyone have any questions? And even if we go a little bit over time, that's okay. Lots of hearts and clapping going on, by the way, Philippe. People liked what you said.
Sorry, I didn't see that because I was sharing the screen. So,
Right. If no one has a pressing question here, what we can do is wrap up with all of these clapping and hearts crossing the screen, and we can follow up by email on one
Um,
of our lists.
Hi, Shane.
Oh, hi.
Sorry to interrupt. I was on mute. Hi, Philip.
Mhm.
Thanks
Hello.
for the presentation. It was nice to understand. It is nice to understand all the toolkits that is provided by About Code. It looks like it has all versatility that is required for managing the open source. My question is relevant to the licensing of this entire tools actually under About Code toolkit.
Yeah.
All these are like permissive licenses, or it also has non-permissive licenses tools. That is like
So,
GPL or AGPL.
so at a high level, uh, all the tools are, with the exception of Deja Code, all the tools are under an Apache license. They contain and depend on a lot of other license inside. Most of the license we depend on are also, generally speaking, permissive or copyleft limited, like LGPL. There are cases where we use some GPL code also, but then when we use that, it's typically used as a command line tool being spawned in its own process. So essentially running at arm's length.
Hmm.
Deja Code is under the Affero GPL. And
Okay.
just a bit of background story for Deja Code. It used to be a commercial tool. We made that open source about a year and a few months ago. And the reason we went from commercial to Affero GPL first is just because it was a big step to make that open source. We wanted to make sure also that it's not something that enables commercial company to build a competing product immediately without contributing it back. So that's
Okay.
really the essential reason. And I don't care about sharing at all. To the contrary, I mean, we're most of the tools, most of the companies that do open source usually ratchet and go from permissive to copyleft
Hmm.
to commercial, and we go the other way around. The thing is that we know, for instance, we have a lot of users which are building commercial solution on top, which is awesome. I wish they were at least contributing a few issues back. A bug. I cannot believe that they don't have a bug when they use scan code or any other tools. So that's the rationale. The data we provide is under CC BY share alike 4.0 or CC BY, depending on the data, which is similar to what you have, for instance, when you use Stack Overflow, which is under weak copyleft license. The intent here is also, it's on the data collection as a whole. It's also to make sure that there's some sharing that's taking place and not wholesome reuse without giving back. From a user perspective, that has absolutely little to zero impact. It's mostly for commercial companies in the space that want to build alternative commercial solution, which we welcome, but we welcome also them contributing a bit back to the welfare of the project and its sustainability.
Okay. Understood. Yeah. Thank you.
Yeah. So, long story short, you're welcome to use and deploy this in any way you want, internally and externally. And what we're working on is a couple of other things. We're working on to reference multiple service providers beyond NextB that can provide support and deployment assistance, for instance, that have specific expertise on the tool suite. So that's one thing. There's also another thing which I've not talked about, but we're discussing with other open source projects which have been showing interest in the space to group and band together with About Code to provide larger solutions. A lot of the work we're doing coming up is also around, for instance, vulnerability reachability. It's one area. And the other, which is to determine if the code that is the root cause for vulnerability is reachable. Important to help with triage. The other thing is open data. So we have a whole lot of project work going on to efficiently being able to share all the data. And that's going to be, for instance, a big contribution in the Octet project with Eclipse. Meaning, for instance, say you want to scan log4j1217 with scan code. The process consists in downloading the source, downloading the binaries, extracting that, running a scan. Eventually, you want to run a special scan that matches the source and the binaries. And if the data is shared and already available, and we already have that publicly available, then you can just fetch the scan and be done with it. And so that's a project that's called Federated Code. And it's very important because that's a way to make all this data available in a way that's practical, meaning it's not under the centralized control. It's easy to mirror, easy to replicate, and really important going forward to ensure we avoid rescanning, revetting, if we can store also corrections in this place, all the projects.
Understood. Yeah. Thank you. Thanks for the details.
Sure.
Thank you, Shane.
Wonderful. Well, in that case, we'll wrap up here, Philip. People have been thanking you in the chat, and I can just add to their words. The incredible work you're doing is changing how open source compliance is working. And what you said today about trying to build an ecosystem around About Code is something that I'd like to ensure that OpenChain project is part of promoting. The idea of having the multiple choice, the co-development is exactly the type of thing we need for sustainability. And I'm delighted that you and Nextbee have this vision. So let's work closely together on promoting this type of atmosphere and initiative.
Thank you. Yeah, that's wonderful, and yeah, definitely. So the problem is very simple: is that we collectively reuse way too much code, which is awesome because it means we really leverage more open source. But it's also a double-edged sword where everybody ends up redoing the same work over and over again. And we need to find ways to avoid that. And we need to find ways to better integrate tools, because without shared open reference data, without tools that can cooperate, collaborate, exchange data together, either we just can't, I think, very simply, there's no way to achieve any kind of compliance or effective business management, or the cost of achieving this was going to be completely prohibitive for any size of organization. The problem is not a small organization, it's for any size of organization. So that's why it's really important that we can find better ways to share these parts.
Absolutely. And that's a message I think starting this January we'll take forward through the whole year. It's not just going to be about code, but everything we're doing in the open source community around management, interoperability, not overlapping, and sharing the development energy so we can get everything done.
Yeah.
Brilliant.
By the way, just for reference, because I had not seen all the participants, but the Octet project we have with Eclipse, I see also Leonie Tischer, She's from Bitsy, which is a major participant in the project, and Sebastian
Yeah,
Subert
hi.
from Art and Double Open, which are also major participants in the project. So the point I'm making here is there's really a lot of organizations which are trying to do the right stuff there to build better open source tools and solutions to the mass for everyone.
That
Yeah.
is an excellent
Sebastian.
message on which to end it. Thanks very much, Philippe, and thank you everyone, Leonie, Sebastian, everyone who had questions, ideas, thoughts, and those people watching the recording. Stay safe, everyone. Talk to you soon. Bye-bye.
Have a wonderful day or night.
Have a nice day.
Bye now.
Bye.